In this question, we're going to look at thermal radiation, a few of the things that can either increase or decrease it, the effects it has on different materials. Right, a lot of what this question goes and it looks at is it's almost a slight variation on one of the required practicals that you will have done. So go back and have a look at the one, I think it's the one on black body radiation, where you use different temperature probes and insulating materials. There was also a separate required practical that you will have done that looked at insulating materials. So a student investigated the properties of 3 types of insulation, right? So it's shown below how they set it up. So in the investigation, different insulating materials were placed in contact with a hot metal plate. Temperature probes measure the temperature of each side of the material. The temperature probes were connected to a data logger. So the fact that it's talked about temperature probes, the fact that it's gone about them being attached to a data logger, they're all things that you'll probably need to go and think about mentioning later in the question. Figure 8 shows how the temperature measured by the temperature probe tube changed over 10 minutes for each of the 3 materials. So what is the temperature of the hot metal plate? Well, the temperature of the hot metal plate will be the maximum temperature that it goes up to. So in this case, it reads off, so it will come out at 80 degrees. 8.2, which material is the best insulator? Right, the best insulator will be the one that allows least of the heat through. So, material C, give you a reason for the answer, because it had the lowest temperature at the end, so therefore must have allowed the least amount of heat through. (8.3) So another student repeated the investigation but doubled the thickness of all 3 materials. Shows how using thicker insulation would affect the results of the second student's investigation in comparison to the first. Right, well, you need to go and look at how that variable is going to go and change things. So the fact that if there's more insulation, all of them are going to have a low temperature rise, because that's how insulation works, right? And this is because the rate of temperature increase would be lower. And it's going to be lower because there's more insulation to get through, regardless of what the type of insulation is. 8.4, so the students could have used a thermometer instead of temperature probes. Right, figure 9 shows the data logger screen and the thermometer. Give 2 advantages of using a data logger and temperature probes compared with thermometers. Right, there are an entire range of things. So, data loggers have high resolution. Data loggers will automatically go and take the temperature. Right, data loggers reduce the risk of misreading. Right, any question where it's going and it's stating that a data logger or some sort of temperature probe or anything connected to a computer is being used, it will always reduce the risk of misreading the result. And it will always increase the resolution because it will have smaller intervals in between the readings. So 8.5, the table 2 gives information about 4 types of insulation that could be used for insulating the cavity walls of houses. Right, remember, a cavity wall is a gap in between 2 layers of bricks that's designed to stop heat going from the inside of the house to the outside by conduction. So explain which one of the types of insulation in table 2 would be the best to use for the cavity wall insulation. Right, looking at those results, it would be the polyurethane foam. Right, and all you'd have to say is simply because it has the lowest rate of energy being transferred. Right, go back have a go at this question, take notes of the amount of marks it's worth, and try and squeeze as many marks out of it as possible.